All right, nobody suggested a second problem to do, so I picked number 16. I did number 14 earlier. This is practice problem number 16 from page 469. As always, we start with what do we know, right? The problem tells us that you have a mirror with a focal length of 10 centimeters. You have an image that is located 16 centimeters from the mirror. It's really important to read carefully, right? This tells you the image distance, DI. Okay, so DI is 16 centimeters. And then it tells you the image height, HI, is 3 centimeters. What it asks you to find in this problem is DO, the object distance, or I think maybe they describe it as the object position or where is the object. That's all the same thing, right? They're asking about DO, what we call the object distance, the distance from the object to the mirror, and the HO, the height of the object. What is the size of the object? So if we know these three things, how do we find these two things? Once again, like practice problem 14, we're going to use the two equations. One is the mirror equation. One over F equals 1 over DO plus 1 over DI. The other is the magnification equation. Okay. M, the magnification, equals negative DI over DO, or also it equals HI over HO. All those things equal each other, right? All those ratios are equal to the magnification. All right, so I'm going to try and find DO first. I'm going to use the mirror equation to find the object distance first. So what do I know? Well, I know the focal length, F, and I know the image distance, DI. So let's plug that in. 1 over 10 equals 1 over DO plus 1 over 16. All right. Now, like problem 14, I've got to rearrange that. I want to get all the fractions on one side, at least the number fractions. And so I get 1 over DO alone on the other side. So I'm going to subtract 1 over 16 from both sides. And what I get then is 1 over 10 minus 1 over 16 equals 1 over DO. Now, again, there are a variety of ways, well, not a variety. There are really two ways you can solve this problem. One, you can take a look at those fractions. You can find a common denominator, which for this one wouldn't be too bad. I don't want to do it, but if you really like finding common denominators, go for it. You can do it. Or you can treat those fractions like the division problems they are, because that's all a fraction is. When you see 1 over 10, you should think 1 divided by 10. When you see 1 over 16, you should think 1 divided by 16. So I'm going to get out my handy dandy calculator, and I'm going to do literally that. 1 divided by 10 minus 1 divided by 16 equals, and I get 0.0375 equals 1 over DO. Now, again, like problem 14, that's not my answer. That's not my object distance. It's the reciprocal or the inverse of my object distance. Now, for me, I've got this handy dandy button. I don't know if you can see it from where you are, but it's right up here. It says x to the negative 1. Maybe yours is the second function of another button, depending on your calculator. I don't know what it is if you're using Demos on the computer. I'm just going to type in x to the negative 1 equals, and I get DO equals 26.7 centimeters. Now, if you don't have that button, or if you can't find that button, the other thing you can do is just literally go 1 divided by that. So DO would be 1 divided by 0.0375. Okay. So I can go 1 divided by 0.0375, and I get 26.7 centimeters. So that is my object distance. That is my answer here. All right. Now, again, you can pause there. You can go back, you can run through that, you can go over the parts where, you didn't understand what I did, but do that until you can get this answer pretty reliably on your own. Remember, watching me do it is great. You need to try it on your own until you can get it yourself without watching. Okay? But now I'm going to move on to the second part of the problem, which is, what is the object height? We just found the object distance. We know the image height. We know the image distance. We can use the magnification equation, but this time we're solving for HO. Okay? In problem number 14, we solved for HI. This time we're solving for HO. No big deal. So let's write down what we know. DI is 16, so we've got negative 16 over DO, which we just calculated to be 26.7, equals HI, which is 3 over HO, which we don't know. Now again, we have this proportion, right? This ratio equals this ratio. And anytime you see a setup like that, you should think cross, multiply, and divide. So cross multiply and then divide. So what I get is negative 16 HO equals 3 times 26.7. All right, I'm going to need a little help with that one. 26.7 times 3 equals, oh, that's a nice number. I get negative 16 HO equals 80. So then I'm going to divide both sides by negative 16. Okay. And I get 80 divided by 16 equals 5. And the answer is 5. Now, I know what you're thinking. Well, Mr. Morgan, what happened to that negative sign? Where did that go? Well, I want you to remember that what that negative sign means is that the image is upside down. It is an inverted image. Okay? So that's what you just have to remember. All right? The image is an upside down image, and therefore it's negative, and that's why this answer ends up negative. I just wrote the positive because really the question is, how tall is the object? It's 5 centimeters tall. All right, so that's how you solve those problems. Two very similar problems, but you need to practice using those equations. Again, the fractions as division problems. I think that's the key. And then finding the inverse. Okay, and then of course cross multiplying and dividing. Just keep practicing them. Keep practicing them until you can do it without watching me do it. And watch me do it as many times as you want to. That's one advantage of me recording these, right? In class, you get to see me once or twice, and now you can do it 10 times if you want. And just keep watching until you got it, okay? All right, good luck, everybody. Take care.